Okay, now we're going to be doing K15, which is graph the solutions to compound inequalities. This is just taking it a step further. In K14, we were solving the compound inequalities. Now we're just taking that inequality that we solved for and putting a graph to it. Okay, so we're going to start over here. This is an OR statement, so it's a disjunction. It should be a disconnected graph. I will start by subtracting 8 from both sides here. That's going to cancel, and that will leave me with f is less than or equal to 7 minus 8 is negative 1. Now this is or union. I will add 6 to both sides here. That cancels. F is greater than 7. Okay, now I have the inequalities. So let's go ahead and graph those. So here is my boundary. I'm going to pick that. It is closed in and everything to the left. Or the boundary is 7. It is an open circle. I don't actually want 7, but I want everything greater than it. This is a disjunction, so they're usually not connected. Okay. Let's go erase this. And now this is a implied and. It is all connected. It is a conjunction. It is connected. Okay, so what I'm going to do, rather than break this up, since there's not too much going on in this inequality, I'm just going to add 6 to each and every section of the inequality. Okay, now here, 10 plus 6 is going to give me 16. Okay, that's going to cancel. 11 plus 6. So I'm sorry, the middle section is just going to be t. 11 plus 6 is going to be 17. So it looks like t can be anything from 16 to 17. 16, 17, and the endpoints as well. Okay, now we're back to an OR statement. This is a disjunction, so it should be that disconnected or broken graph. We'll go ahead and add 5 to each side here. Okay, adding 5 doesn't change the inequality, so I've got W is isolated. 10 plus 5 is going to be 15. Or, that's the union sign. Okay, I'm going to subtract 16 from both sides. And when W is isolated, it is less than or equal to 0. Okay, so we've got this needs to get graphed. W is greater than 15, so the boundary is at 15. It is not an equal to, so we're going to undo that, and we want everything greater than that. We also want 0 and everything less than 0. Okay. Again, a conjunction. So this is all connected. It's an implied and statement. Once again, negative 5 is less than or equal to x plus 9, and x plus 9 is less than negative 2. This is pretty simple. Not much going on to the variable inside, so we'll just subtract the 9 to get the x by itself and subtract it in all 3 areas. Negative 15 minus 9 is going to be negative 14, which is less than or equal to. The 9's cancel, and I'm just left with x in the middle. And then negative 2 minus 9 is going to be negative 11. So x can be anything from negative 14 to negative 11. And including 14, but not including negative 11. This was a mistake on my part. Don't make silly mistakes like that. All right. Now, we're back to an OR statement. We have some division going on here. We're dividing by a positive, so that's not going to really affect anything. So we'll start on the left-hand side and subtract 13. Okay, this is going to give me 3p is less than or equal to 19 minus 13 is 6. Divide both sides by 3, and p is going to be less than or equal to 2. Apologize for the handwriting here. Or union, add add 11 to both sides, add 11 to both sides. That's going to give me 4p is greater than or equal to 5 plus 11, which is 16. Divide both sides by a positive 4. Dividing by a positive will not impact the inequality, so p is going to be greater than or equal to 4. So in an or statement, if you have one condition, it's got to go on the number line. It's not just an overlap. So here we're starting from 2, including 2, and every value less than it. Here we are starting at 4, including 4, and every value greater than 4. So in an or statement, most of these are a disjunction and a disconnected graph, so a break in the middle. Okay, all connected. You can see that they're starting to get a little bit more difficult. For the sake of space, I'm going to keep doing it the way I've been doing it, but if you're uncomfortable, you can always write this twice as 16 is greater than or equal to 5x plus 16, and 5x plus 16 is greater than 11. Break it up into two simpler problems, and you can make life a lot easier for yourself. Okay, I'm going to go ahead and just subtract 16 from each section. Okay, that's going to give me, let me do it up here, 0 is greater than or equal to, that cancels, 5x, which is greater than 11 minus 16 is negative 5. Now, I'm going to have to divide by 5, and we do it in all 3 sections. So 0 minus 5, or 0 divided by 5 is 0. The 5s can cancel here, just leaving you with x. And negative 5 over 5 is going to be negative 1. So x can be any value between 0 and negative 1, not including negative 1, but including 0. So this is a little bit confusing because it's flipped. We're actually going from negative 1, but not including it, to 0. Okay. All right, connected again, starting to look a little bit challenging. It's not going to be as bad as you think. We'll start off by subtracting 6 in all 3 sections. Okay, anything plus its opposite is 0, which is greater than or equal to, that cancels. So now we've got 13y in the middle, and greater than negative 7 minus 6 is negative 13. You're going to see that there's really no way to graph fractions right now. So just make sure that your math works out that everything is evenly divisible. If it doesn't, then you probably did something incorrectly. Okay. So all 3 sections need to be divided by 13. 0 over 13 is 0. Those cancel. So I've got 0 is greater than or equal to y, which is greater than negative 13 over 13 is negative 1. Okay, another way to write that is 1 is less than y, which is less than or equal to 0. I just took this extra step to rewrite it backwards so you can see it goes from negative 1 to 0, not including negative 1. Okay, I'll do one more problem because this one looks a little bit intimidating. Okay, but don't panic. We're doing one problem at a time. So we'll start on the left-hand side, and this looks intimidating to most people. It's a fraction, so that is in implied parentheses. So the first thing I would do is multiply both sides by 3. Okay, when that happens, those are going to cancel, and I'll be left with something that looks a lot nicer, just the numerator, p plus 4, which is less than or equal to negative 2 times 3, which is negative 6. You can subtract 4 from both sides, and p is less than or equal to negative 10. union, or we do the same thing on the other side. Let me just change color so you can see. Same thing on the other side. I'm multiplying both sides by 2 to back out division. I can't really write this. Let me try it again. So I'll multiply both sides by 2. The 2's cancel. I now have P plus 4 is greater than 6 times 2 is 12. We'll subtract our 4. Okay. P is greater than 12 minus 4 is 8. Okay, so -10, including -10, anything less than that. And we want 8, but not 8, but everything greater than that. All right, so this looked a little bit more intimidating, but just follow our rules for solving. Leave the numerator for the end and back out the division first because those are trapped in parentheses. If you had to multiply by a negative value, you would flip the inequality. If you had to divide by a negative value, you flip the inequality. Those are the only things that you should watch out for as you get closer and closer to 90. Okay, guys, good luck.